Okay, today we'll solve some more problems. Continuation of the topic, magnetic coupling circuits. So last class also some problems solved. Now let me continue with some more problems. So here, if magnetic coupling circuit is like this, two current sources, primary side I1, secondary side I2, both are AC sources. Then what is the total energy stored? What is the total energy stored? So this is the formula. Just remember the formula. Half L1 I1 square plus half L2 I2 square plus M I1 I2. If this coupling is moving downside, then here you get minus. Any one of the dot moving or disturbing, you get to minus. Both the dots are disturbed, again you get a plus. So this is energy stored in primary, this is energy stored in secondary, this is energy stored in coupling. So this is the total energy stored. The derivation not so great thing, but if anybody is interested, just go through it. But remember this formula. So this is sometimes what is the total power in the transformer is zero. Total power, I mean dissipated or a loss for any ideal transformer. For any ideal transformer, power loss is zero. So that is the proof. Power in primary is V1 I1. Power dissipated in secondary is V2 I2. So V1 I1 plus what is V2? NV1. We know this formula. V2 by V1 is equal to I1 by I2 is equal to N. So what is V2 value? N into V1. Okay. But here I2 is not I1 by N. So any transformer, I1 is entering at the primary, I2 is leaving. I2 is leaving. So what is leaving is minus I2 now. What is leaving is minus I2. So I1 by minus I2 is equal to N. Therefore, I2 is equal to, from this I2 is equal to I1 by minus N. So that is substituted here. Now simplify N cancel, minus V1 I1. This is plus V1 I1 is 0. So this is the proof that the total power dissipation in the ideal transformer is 0. Then sometimes this is also useful. This coupling can be replaced with another equivalent. Left side parallel with L1. Now it is a transformer now. This is the coupling. This one is basic coupling circuit is equivalent to, now this is a transformer. Transformer in terms of turns ratio. So 1 is to root L2 by L1, then here L1. And if you write expression for V1 and V2, you get similar expressions. Whereas here L2 is taken this side, again transformer here, root L1 by L2 is to 1. root L1 by L2 is to 1. Here 1 is to root L2 by L1. If it is root 1 is to root L2 by L1, L1 is in primary side. If L2 is in secondary side, root L1 by L2 is to 1. The idea in this is how we can replace coupling circuit with the transformer. So they are identically equal. With the help of current distribution and if you write mesh equations, both will be same. There is one more derivation, the primary impedance. We used this earlier. Zn equal to ZL by N square. So how to derive that? Primary input impedance is V1 by I1. V1 equal to V2 by N. I1 equal to I2 into N. Now further, V2 by I2 is equal V2 by I2. This N will come down. So N square. But what is V2 by I2 is ZL. ZL by N square. So it's a simple proof. Zn is ZL by N square. We are looking from secondary, Zn is ZL into N square. So all these possible formulas I am telling you, remember, helpful in solving problems. Now there are nearly 21 problems are there. Now let me explain all these problems one by one. All not possible today. Some problems today. Next class, last class, remaining. So here is the problem. Okay. So here one amplifier equivalent circuit given. Amplifier V in of 1 volts RMS, 200 V in, here 900 ohms. Then transformer with A is to 1 and loaded with 4 ohm. What is asking? Find average power in P average in 4 ohm or not of if. Find average power if 4 ohm connected to amplifier. 4 ohm is connected to amplifier. So this transformer is not there. This 4 ohm speaker directly if it is connected to amplifier, what is the average power transferred? That is A bit. So V in is 1 volt. Na? What is this will be 200 volts. Then how much current will flow here? 200 by 900 ohms. What is this 4 ohm speaker connected here? Na? So 900 plus 4. You will get this much current. That is the current flowing through this 4 ohm. Now what is the power? I square into R. Simplify, you will get the answer. That is A bit straightforward. B bit, when transformer is present between the speaker and amplifier with A equal to 5, find the average power dissipated in 4 ohm. Under that condition, what is this resistance is 4 now? Then what is the primary? 4 divided by 1 by A square. 1 by A square. So that is the primary impedance. So Zin is equal to 4 by 1 by A square. But A given as 5. So you are getting 100 ohms. That means impedance present here is 100 ohms. Now what is the voltage across 100 ohms? So it is like, it looks like a voltage source of 200 volts. V in is 1, so 200 volts RMS. Then this resistance of 900 ohms. then this resistance of 100 ohms. So here we have to find the power. We can find current I square into this or V square by R. Any one of the way you can. So what is the voltage here is 200. This is the 200 into 100 by 900 plus 100. So first here finding the voltage. 200 into 100 by 900 plus 100. We are getting 20 volts. 20 volts. Power is not 100. Power is in 4 ohm. Now this 20, when it is coming other side, 20 by 5. 20 by 5 is 4 volts. So what is the voltage coming in the secondary is 4 volts. Here coming is 4 volts. Then what is the power? V square by 4. So it is 4 watts. Even we can also do V square by R. V square means 20 into 20 by 100. Again 4 watts. Even here itself. This 4 only reflected here as 100 ohms. So finding power in 100 ohms is equivalent to finding power in 4 ohm. Either way you can do. This finding voltage again, what is jumping in secondary, that much lengthy not necessary. Even directly also you can do it. So this is also best idea. Then third question is find A, the turns ratio A, to get maximum power and find the maximum power. So what is the maximum power condition? Load resistance to source resistance should be equal. So 900 is equivalent to 4 by 1 by A square. Impedance matching. Solve for A. We are getting 15. Then repeat the B bit. What is B bit? When A equal to 5, we find power. Na? So here A equal to 15. Repeat the concept of B bit. Just to solve yourself, you will get the 11.11 watts. Another problem, show the possible location for the dots. So the one coil 1, 2, coil 3, 4 are undoubtedly coupled. No doubt they are coupled, but coupling is indicated with the dots. So where to locate the dot? Dot at 1, 3 or 1, 4 or 2, 3 or 2, 4. So how to select the dot? The best idea, what I told you, to understand the coupling, always send the current. Send the current from either 1 or 2, anything all right. So if I am sending from 2, how this will go? This will go like this. This is the current direction. And using right hand thumb rule, use the right hand thumb rule, 4 fingers indicate the current direction in the coil, thumb indicates the flux direction. So like this, flux is flowing. Like this, flux is flowing in the core. This is the flux direction. Flux direction under the assumption of sending current from terminal 2. Now send current from 3 or 4, anything. And answer remains same. So if I send from 3, this is the current direction. This is the current direction. Again use right hand thumb rule, and this indicates 4 fingers current direction. Then again flux will be downward. This is the flux direction. is the flux direction. So how these two fluxes are flowing? Opposite. Na? Fluxes are flowing when we send current from 2 and 3. Fluxes are flowing in opposite direction when we are sending current from 2 and 3. So if I place dot at 2, I have to place the dot at 4. When I am sending current from 2 and 3, if flux is in same direction, then I will place dot at 2 and 3. Because flux is flowing in opposite direction, I should place dot at 2 and 4. It is equally correct to 1 and 3 also. So what is the answer? 2, 4 or 1, 3. Both are correct. If you send current from 4, you try yourself and the answer remains same. That's what I told you. Na? Dot indicates the winding direction. It will not indicate the current direction. Coupling is disturbed by winding direction. Coupling never disturbed by current direction. So that is point to be observed. So this is another problem, coupling with theorem. How coupling linked with the theorem. So what is the problem is, so I am not giving any time to draw the problem. When you listen the video, you pause it, copy the problem, try to solve yourself, then play, then understand how I am solving. That is an advantage of video lectures. Any number of times you can see, depending on your speed, you can pause it. Even you can, if you are thinking I am explaining slowly, you play at a speed of 1.25, you can play speed of 1.5, you can finish the video at faster rate. So even that technique also you can apply, right? Now, this is a problem 1:4, and here current Ix flowing, here 20 Ix. First look at the problem and understand what is given, what is asking. So he's asking RAB, so resistance here. This is the problem. So RAB we have to find. To find RAB, how this problem looks like? RAB is nothing but indirectly what is asking? R Thevenin is asking. But to find R Thevenin, in theorems, 3 categories we studied. First category, all sources are independent. So directly we find V Thevenin independently R Thevenin. What is second category? Network contain dependent and independent sources. We find compulsory V Thevenin, I Norton, ratio will give R Thevenin. But here, this comes under third category, all sources are dependent. When all are dependent, R Thevenin directly not possible. As per the definition also not possible. So I told you another technique, apply 1 volt across AB, but this 1 volt is not DC. There is a transformer. Na? Transformer never transfer the DC, it will transfer only AC. So AC voltage of 1 volt is applied. Then because of 1 volt, what is the current I? 1 volt by I is nothing but resistance, that is nothing but R Thevenin. So that is the idea. When 1 volt is applied, what is voltage across 20 ohms? Is 1 volt only. Na? Then what is Ix will be 1 by 20. So Ix is 1 by 20. Then this is 20 Ix. So that means 20 into 1 by 20 is equal to 1 volt. So what is the voltage here coming? 1 volt. Then here 1 volt applied. What is the voltage across primary? Also 1 volt. Na? When 1 volt is applied, 1:4, how much voltage will jump here? 4 volts. So this side 4 volts, so this side 1 volt. What is the potential difference here? 3 volts. Then what is this current I2? I2 is nothing but 4 minus 1 by 60 equal to 3 by 60 is equal to 1 by 20. Okay, 1 by 20 is I2. Now find this current is I1. So what is the transformer formula? I1 by I2 is equal to 4. Remember, this is plus 4 or minus 4. I1 is entering at dot, I2 leaving from the dot. So compulsory I1 by I2 is plus 4 only. Then what is I1? 4 into I2. So this is 4 into, but what is the I2 we got? 1 by 20. So it is 4 by 20. What we are looking for I, but this I is nothing but Ix plus I1. What is Ix? 1 by 20. What is I1 is 4 by 20. Total 5 by 20 equal to 1 by 4. But we want R Thevenin. R Thevenin is nothing but V by I. What is the V applied? 1 volt. What is the I we got? 1 by 4. So this is what 4 ohms. 4 ohms is the answer. Okay. Second, I have given homework. I am giving homework. If one of the dot is 2.61 is the answer. If dot location is changed, if any one of the dot, this is coming down or this is coming down, what is RAB? The answer is 2.61 given. Now try yourself. See, these homeworks are really very, very important and you will not get that much easily answer. You have to struggle. Process of struggling, you will learn many things. You will learn many things. Though, if you think more and more, your mind will be active, mind will be sharp. That sharpness is helpful in the competitive examinations. So don't just go through all solve means mind, your mind never think. So some problems you have to think, some problems you have to solve yourself. That really helpful a lot in the exam. There is another problem for what value of N2 by N1, again a transformer, maximum power transferred to 8 ohms. This is actually, this 300 is a complicated one. It takes, I think unnecessary will get confused. Actually answer is infinite. So I am just removing this. We'll answer only this. For what value of N2 by N1, maximum power transfer to 8 ohms. So this value is 8 ohms. Then what is this value is 8 by N2 by N1 by N1. And this side also should be saved now, maximum power to be transferred. So replace this with, remember, maximum power transfer is applicable always on Thevenin equivalent. But this is not in Thevenin equivalent. So first replace with the Thevenin V Thevenin. It's an AC source. V Thevenin. And this is R Thevenin. And load is connected here. What is this load is 8 by N2 by N1 square. Okay, so R Thevenin, how to find for what value of N2 by N1 maximum power transfer to maximum power transfer. What is maximum power is not asking. So R Thevenin only we have to find. How to find R Thevenin voltage source short? 600 300 parallel. Means 600 parallel with 300. So you will get 200 will come. So this is 200. For maximum power, this 200 should be equal to 8 by N2 by N1 square. So from this, N2 by N1 square is equal to 8 by 200. Now N2 by N1 is equal to root of 8 by 2. This is the answer. If he is asking maximum power also, then you need to find VThevenin. How to find VThevenin? 30 volts dividing between 300 by 900. So how much you will get? 10 volts will come. This is 10. Then how to find maximum power? Vs square by 4 into RL or RS. Anything. So what is Vs? 10. 10 square by 4 into RS. RS, RL will be same. So that is 200. Is the answer. If they ask maximum power, you need to find VThevenin also. It's a repetition of Thevenin's theorem, but just transformer if it is there, how to solve it. There is another problem, location of dot from the waveforms. Okay, here transformer is given, but dots not given. So that dot we have to find with the help of waveforms. So here I1 is given. This I1 waveform is given, and V2 waveform also given. This is the triangular wave, this is the square wave given. Find dot and also M. M we have to find where to locate the dot. Okay. So to find the dot, and here terminals given A, B, here C, D. So where to place the dot? So answer is A comma C or B comma D is answer given. But how do you select it? Just to see here positive current increasing. So current entering here. Current entering here. Then V2 is again positive. So what is the basic definition I told you in the beginning? A current entering at primary induce open circuit voltage in the secondary. If it is a positive, that means what? Winding directions. So if you recollect the first coupling circuit, so here positive current entering, what is voltage coming is also positive. It indicates what? So dot should be here. If dots are placed here, condition is satisfied. Current entering at dot, sensing at dot is positive. So positive current entering, voltage is positive. Then current here decreasing, negative side, changing. Voltage also negative. So like that it will go. So this is sufficient. This portion is sufficient to test it. Entire portion not necessary. Now we understand the dot. Now what is the expression for V2? V2 mutual induced EMF. V2 is equal to M di1 by dt. Na? M di1 by dt. But what is V2? Already 2 volts. So this is 2 already there. M we don't know. Now d by dt of I1. What is this I1 expression? If this is 1, this is 0.5. Na? So what is the slope? Slope is 1 by 0.5 milli into 10 power minus 3 t. So this you are differentiating. If you differentiate to t will go, and you will get 0.005. Then solve for M. This, okay. This topic you need to read Eighth and Kemerly. Basic, I mean, start with Eighth and Kemerly, any edition of your choice. Then Van Valkenburg, then D. Carlo Lim. These three books in that order you have to refer for better understanding. There is another problem. Vs given 50 ohms, 2 Henry. Dots also mentioned 2 Henry, 10 Henry, 3 Henry. So I2 given, I1 given, 100 ohms given. So this I1 value given, I2 value given. Find V2, V1, Vs. Find V2, V2, V1, Vs. So this is the simple we know now formula. V2 by V1 is equal to I1 by I2 is equal to N. So V2 is V2 polarity will take this way. V1 we will take like. So V2, even all those things not necessary. V2 is nothing but what is the current here? So 100 into I2. Or if you yeah. So this V2, one is the self-induced EMF, other one mutual. So one expression is V2 is equal to you start positive, go to negative. So that is 10 di2 by dt. 10 di2 by dt. 10 di2 by dt. We are going from positive to negative, and this direction same plus. Then what is the mutual? I1 entering at undotted, sensing at undotted is plus. So that is again plus, and M is 3 d by dt of I1. So I2, I1 given, I2, I1 given, substitute, solve for V2. So that answer. Like that, V1 also given. V1 is again self and mutual. And just try yourself. What is V1 expression? 2 di1 by dt. And I2 entering at undotted, sensing at undotted, once again plus. So that mutual M is 3, then D I2 by D. I1, I2 substitute, simplify, you will get V. Then what is Vs will be? Vs is equal to 50 into I1 plus V1. V1 already done. Then I1 is given, simplify, you will get Vs. So answers are there, you can just cross check yourself. Find total energy stored in the network at T equal to 0. If 1.2 Henry is open and short. This is based on the derivations we have done. When any coupling circuit, when secondary is open, what is L equivalent? L equivalent is L1, that is 0.3. Is asking total energy at T equal to 0. What is cos 0 is 1. So 10 ampere current flowing. 10 ampere flowing here, what is energy is half into L equivalent to 0.3. Then how much current to 10? 10 square. So simplify, you will get 15 joules of energy. Then B bit L equivalent. When it is short, remember there is one formula L1 minus M square by L2. This formula derived. So L1, L2, M substitute, you will get L equivalent. Then use half Li square. Then energy is nothing but half into L equivalent, whatever you get substitute. Then current to this remains same. Simplify, you will get 11.225 joules. So it's an application of the derivation what we have done. If it is open, what here M directly not given in the problem. L1 given, L2 given, but K given. You can find M na. So that M is useful here. There is another problem if ZL is 80 minus 60. Again transformer 5:1. 5:1. This current is I1, is I2, V1, V2. So 5:1. ZL given 80 minus J60. Find the average power delivered to ZL if various conditions. I2 given, how to do, V2 given, I1 given, V1 given, Vs given, how to do it. So it is the topic is magnetic coupling circuit with the construction of power triangle. This is a combined topic. So what is asking average power? Average power means P we have to find. A bit to I2 given. And I2 given, how to find P? Simply I square R you can use it. So what is IRMS 2 amps? Na? So 2 square. But what is the resistance part? 8. So you will get 320 watts. So this is the 320. Next B bit. B bit to V2 given. When V2 given, how to find power? Don't use V square by R. This V2 is not across 80 ohms. This V2 is across ZL. So first to find current I2. How to find the current I2? V2 by ZL. Okay. I2 is nothing but V2 by ZL. So what is V2 given? 100 of 30. What is ZL given? 80 minus J60 is also 100 of some angle. So it will be 1 of angle something. Then what is the power P? I square into 8. But what is I1? 1 square into 80 is 80 watts. Then C bit I1 is given. If I1 is given, first find out I2. How you can find I1 by I2 is equal to 5:1. So that is 1 by 5. What is I2? We want I2. So I2 is 5 into I1. What is I1 given? 0.5. 5 into 0. So 2.5. we want to power. So 2.5 square into 80. Simplify, you will get 500 watts. Next, V1 is given. When V1 is given, use this formula. V2 by V1 equal to 1 by 5. So find out V2. Then repeat the procedure of B bit to procedure. Okay, then you can find out. Now Vs. This Vs is important. Vs is given, how to find the power. When Vs is given, what is the impedance? ZL. Na? If ZL is given, what is the primary impedance? Is ZL by N square. So total impedance you have to find. First find the total impedance. That is 1K plus, is 1K na? 1K plus ZL by N square. 1 by 5 square. So using this ZT find out. Then find out I1. What is I1? Vs by ZT. Once you get I1, repeat the procedure of C bit. Now repeat procedure of C bit. So here substitute ZL, ZT, Vs by ZT, I1. Once you know I1, how to find power, repeat the procedure of C. So answers already there, just cross check. If you listen all previous topics only, you will understand this topic. Because all problems linked with the previous topics. If you just go through this video directly, you will not understand. Now, write loop equation. This is asked in the JNT exam. Just ask you to write the loop equations for the circuit shown. So here loop current I1, here loop current I2. Now here, if this loop current I1, what is this current is again I1. So I1 is entering at dot, assume sensing at dot, assume sensing at dot, entering at dot, sensing at dot. Here it is plus, entering written wrong. This is plus. No, sorry. Okay. I1 entering at dot, sensing at dot is plus. But this I2 entering at undotted, sensing at dot. This is minus, correct? This is minus, correct? This should be this. I1 entering at dot, sensing at dot is plus. But I2 is entering at undotted, sensing at dot is minus. So minus M di2 by dt. Now you write the equation. V1 of t is equal to R1 into I1 of t plus 1 by C1 integral I1 dt plus L1 di1 by dt self. Going from positive to negative is plus, but value is minus. So minus M di2 by dt. Then other equation L2 di2 by dt. Here going from minus to plus. So minus, but value already plus. So minus M di1 by dt plus 1 by C2 integral I2 dt plus V2 equal to 0. So just asking to write loop equations. To solve, you have to apply Laplace transform. asked in IES, I think. Two magnetically uncoupled inductive coils, hence quality factor Q1, Q2 at the chosen operating frequency. The resistances are R1 and R2. When connected in series, their effective Q factor at the same operating frequency. So what is given is two uncoupled inductive coils. So this is one inductive coil, this is another inductive coil, and individually this quality factor is Q1, this quality factor is Q2. Then now both are connected in series. Is asking what is the total quality factor. So what is the quality factor formula? Omega L1 by R1, Q1. Q2 is what? Omega L2 by R2. What is the total quality factor? Omega into L equivalent. What is total L equivalent without coupling? L1 plus L2. What is the total resistance? R1 plus R2. Simplify. Then omega L1 plus omega L2 by R1 plus R2. But what is omega L1? What is omega L1? Q1 into R1. So Q1 R1 plus Q2 R2 by R1 plus R2. So you are finding total quality factor in terms of Q1 and Q2. This is a more description, but problem logically you have to solve. The following arrangement consists of an ideal transformer and an attenuator. Here there is an attenuator which attenuates by a factor of 0.8. This attenuation is 0.8. AC voltage V WX1, voltage at WX1 is 100 volts, is applied across AC voltage WX1 is applied across WY to get open circuit voltage V YZ1 across YZ. Next on AC voltage V YZ2, 100 volt is applied across YZ to get an open circuit voltage at WX2 across WX. Then voltage at VZ1 by VWX1, VWX2 by VWZ are respectively. So little bit observe carefully. Case 1. What is the transformer here ratio? VY prime. This voltage is Y prime. This by this equal to 1.25 by 1. That is N2 by N1. Okay. So Y prime Z1 is equal to N2 by N1 VWX1. 1 indicates case 1. So N2 by N1 is 1.25. What is the voltage applied here? 100. So how much you get here? 125. So when 100 is applied here, how much you are getting? 125. Okay. VYZ1 is 0.8 times of 128. So this attenuation, it is like a potential divider. How much is attenuating? 0.8. So 125 is multiplied with 0.8, you are getting 100 volts. So what is the voltage here? 100 volts. So VYZ1 by VWX1 ratio is asked 100 by 100. So this is simply 100 by 100. Now case 2. Case 2, AC voltage VYZ2, 100 volt is applied across YZ to get open circuit voltage VWX2 across WX. Now, here voltage is applied. Case 2, 100 volts applied here. This resistance is 0.8 R, 0.2 R. This total resistance divided 0.2 R, 0.8 R. What is applied here? 100. Now, when this voltage is applied, it is like a primary open transformer principle. When primary is open, secondary current, ideal transformer. When primary open, what is the current here also? 0. Any transformer, assume voltage is applied in the primary, secondary not loaded. So secondary current 0, that will force primary current also 0 ideally. The same way, when primary is open, voltage applied in secondary, then primary current 0, that will force to secondary current also 0. So this is based on transformer principle. So that's why this current is 0. This is 0 because primary is open. Now when this is 0, whatever voltage is applied, same voltage will come here. Current 0 means here drop 0. Na? So what is the voltage here? 100. Then how much will come here? 100 by 1.25, 80 volts will come. Now he's asking ratio, na? 80 by 100 is the answer. So generally case 2, this current 0 idea is important. Otherwise different answers will come. So this current is 0, this is 100 applied, same 100 is coming, reduced by 1.258. So answer is 80 by 100. Now I stop at this moment. We'll continue with class. Thank you.